Hi guys, welcome to your Unit 3 notes. Today is Lesson 1, Solving Proportions. By the end of the day, you will be able to solve proportions. So here we go. As a bit of a warm-up, let's work on putting decimals, taking decimal form of percents. So this is very straightforward. All we're going to do is we're going to take our decimal point right here and move it back twice. So to change a percent to a decimal, you just need to take the decimal point and move it 1, 2 places to the left. So taking this decimal point, we went 1, 2, and that gives us 0.75. Now do part B. What do you think it will be? Take this, move it 1, 2, and that gives you 0.333. Finally, predict what C will be. So we take all decimal point, we move it 1, 2. Oh, but there's nothing there. Pretend like there's a little 0 there. That gives us, pretend like we go 1, 2. Okay, now pretend that there's a 0 there. That will give us 0.07. Awesome. Okay. Now let's work on simplifying fractions. So to add these two fractions together, we're already in good shape because we see that they have a common denominator. So when you have a common denominator, you're going to keep that common denominator common, put that right in the bottom, and then you can put whatever's on top right on top. So that's 1 plus 3 over 10. And 1 plus 3 over 10 is 4 over 10. And typically we would be done, except we can reduce this. 4 is the same thing as 2 times 2, and 10 is the same thing as 2 times 5. So 4 over 10 is equal to 2 over 2 times 2 over 5. Now these 2's will reduce out. So this is the same thing as 2/5. In our next one, they don't have common denominators. 1 is the same thing as 1 over 1, and that's not a common denominator. However, 1 is also the same as 5 over 5. So now that we have a common denominator, we can make that subtraction a reality by going 5 minus 2 all over 5. Awesome! And 5 minus 2 is 3, so we have 3/5, which does not reduce. And finally with F, we don't have a common denominator, but that's okay, because look at what we're doing. We're multiplying. Awesome. So we could multiply straight across, giving us 28 over 50, and then we would have to reduce that from there. But because we like to be efficient with our time, we can check out, oh, hey, remember 4? 4 is equal to 2 times 2. And remember 10, that's equal to 2 times 5. So we can reduce out a 2 from each of, we can reduce out a 2 from each of those. So instead of using 4 and 10, we can use 2 and 5. So 7 times 2 is 14, and 5 times 5 is 25, and you guys, I totally missed my fraction line. There we go, 14 over 25. Super. Oh, we need to make that our final answer. Okay, now that we've got our nice review down, let's work with proportions. So you've heard this term before. Hopefully you've heard of the term ratio. When you hear ratio, just think fraction. You're comparing two numbers with division, and that's like 15 over 10. That's a ratio. You can also write a ratio. There's like a 15 to 10. You can also write it with words missing. 15 to 10. To 10, like that. Those are all fine. Those all count as ratios. When you hear per, that's also an indicator that you have a ratio. We'll get into that a little bit later. Okay. Now when you take two ratios and you say that they're equal, we call that a proportion. For example, we say that 10/15 is equal to 2/3. Cool. We can also say that, x over 5 equals 8/20. And then we can use this equation to solve for x. Isn't that great? So great. Okay. So, your key idea of the day is right here, and it's the idea of cross products. We say that every proportion has two equal cross products. And what that means is, oh hey, that's your key idea down here. Why did I put that in there twice? I really don't know. So I'm just going to show you in this box down here. Okay. So if you have two fractions, if you have two ratios, you have a over b equal to c over d, then you can multiply them together. You can get a times d equal to b times c. As long as you're going across that equal sign, those are going to be equal to each other. And why is that the case? Well, let me show you. First, I'll show you with numbers, and then I'll show you with letters, showing you that it doesn't matter what numbers we pick, they all work. Okay, so we looked earlier at 10/15, and I claimed that that was equal to 2/3. Well, let me prove it to you. Let's get rid of this 15 right here. So if I multiply both sides by 15, these 15s are going to cancel out, leaving us with 10 equals, and then what do you guys want to do? Do you want to reduce the 3 and the 15? Reduce 1, multiply? Let's just multiply across. So this is 15 over 1. So 2 times 15, that's 30. And 3 times 1 is 3. Well, is 10 equal to 30 over 3? It is, because 30 over 3, that reduces to 10, and 10 equals 10. Cool. Isn't that great? Hey guys, guess what? It doesn't matter what numbers you use. If we picked any number A, and we picked any other number B, no matter what it is, you can replace these with literally any other number as long as it's not 0. And we have, C over D, because we love the alphabet. Well, again, let's solve. So if we have, we multiply both sides by B, these B's will reduce out, giving us A, and then C times B all over D. Well then, we can multiply both sides by D to get rid of this. So we have D times A equals, and then these reduce, just like these reduce, giving us C times B. Or, if you, like me, like to have things in alphabetical order, that's A times D equals B times C. Oh, hey, guess what, guys? That's exactly what our rules said. AD equals BC. Whoa, amazing. Okay, there you go. I proved it to you. You're welcome. So the way you solve proportions is by using this fun cross product rule. So that's exactly what we're going to do. We're going to multiply 5 times n equals 3 times 75. Oh, I'm sorry. I forgot to write that down. Okay. 5 times n equals 3 times 75 because we multiplied across the equals sign. And now we have this wonderful equation. We have 5n equals 225. All we have to do is solve for our n variable. So we we divide both sides by 5 to get n all by itself, and that gives us 45. There, we did it. We solved it. Let's check. Is it right? Always check your solution. Oh, guys. Look at that check mark. Okay, anyway, that's my win of the day. Is it true that 5/3 equals 75 over 45? Well, 75 and 45, those are both divisible by 15. So that's exciting. 75 is 15 times 5. And 45 is 15 times 3. And lo and behold, We reduced those out. You got your 5/3. We did it correctly. Amazing. Yeah, that check mark is not nearly as good. This one is perfect. I'm gonna like frame it. It's so good. Okay, cool. But what happens when you have this and you have variables twice? Oh, man. Well, let's do what we know. Let's do what we know and see what happens. Okay, so y times 10 is the same thing as 10y, and 8 times y plus 4. Oof. Well, we did our cross multiply, and you know what, guys? If that did not make your lives easier, that's okay. What else do we know? Well, hopefully you remember the distributive property, so we can check this 8 guy, distribute him to both terms here. So that's the same thing as 8 times y plus 8 times 4, because our 8 goes to each term. Right? Now I'm going to do 2 steps in 1 step, just to save room. So we can subtract 8y from both sides, and these will cancel out. And 10y minus 8y is 2y. And then the second step in the same step, 8 times 4 is 32. So we get 2y equals 32. And then we're almost done. We hiccup, and then we divide both sides by 2, giving us y equals 16. And then we nail it. Because it's so good, right? We nailed that problem. Well, let's check. Let's check if it's true. We got to honor the perfect check mark, you guys. Oh, so good. Okay. So is it true that 16 over 8 equals 16 plus 4 over 10? Maybe? We don't know. Well, 16 over 8, that's 2. That's nice. And 16 plus 4 is 20 over... Oh, hey, look. That's so good. Man. Guys, I peaked. I peaked today with this check mark. It's so good. I'm so proud of it. Sweet. Okay, that's great, Miss Van Dyke, but when we use this in real life? Well, I'll tell you. We use them in conversions. Yay! We use conversions when we need to measure something. We need to measure like the same thing. Okay. So here we have ounces and we have pounds. Those are different units, but they're both measuring weight. Right? And then over here we have kilometers, kilometers, kilometers. We have kilometers and miles. These are both units of distance. Let's find out. So I tell you that I have a cat. I don't actually have a cat, but let's say I have a cat and the vet says, yep, she weighs 72 ounces. That's great. What is that in normal people pounds language? Well, let's find out. So I know that there are 16, I'll do this in gray, because my cat is colorblind. I don't actually know if cats are colorblind. But there you go. So I know that there are 16 ounces in 1 pound. But I don't know how many pounds I want. It's my big old question. So I know that I have 72 ounces. And I'm like, how many pounds is that? Well, why don't we just call that like P for pounds? Ta-da! Okay, well, now that we've got our equation set up, let's cross multiply and see what we get. So we have 16 times P is 16P equals 1 times 72. Oh, that's so nice. I love multiplying by 1. 72. Super. Duper. Okay, now we want to get P all by itself, so we divide by P, or not divide by P, sorry. We divide by 16 on both sides, giving us that P equals, oh, that's not nice, 4.5. Nice. 4.5. Ta-da! Man, that's such a good oval, too. And it wasn't like a hold and make it perfect one either. Man, good job, me. Okay, anyway. Now, for my cross-country runners, we will often run a race that is 5 kilometers long. By the way, Kilometers is the American way to say it. Kilometers. So kilometers is the US way to say it. Kilometers is the European way to say it. That's your fun pronunciation fact of the day. Okay. Now let's say that you know that there are 1.609 kilometers in every mile. Why you know that? Well, you're just full of fun facts today, aren't you? We want to find out, hey, how many miles is that? If you can run a 5K in 24 minutes, is that respectable or is that really slow? Do we say 25, 24? We'll go with 24. Is 24 minutes a good 5K time? Let's find out. Well, we know that we did 5 kilometers. We want to know how many miles, miles is that? Okay, let's cross multiply. 1.609 times m is 1.609 m. Cool. And the real tough one, guys. 1 times 5 is 5. Super. And then for this one, we could break out our calculator, or we could do some sneaky long division. Either way, we want to do 1.609 divided on both sides so that these guys cancel out. 5 divided by 1.609 is 3.108. So the miles we have is 3.108 miles. So what do you think? Is running 24 minutes, 3 miles in 24 minutes, is that respectable? It's about an 8-minute mile for 3 miles in a row. I'll leave that up to you. I think that's pretty decent. Like, for a cross-country runner, that's kind of slow. But for a normal person, I think that's pretty good. There we go. Okay. All right, we're almost done, you guys. We're going to leave the running behind, and we're going to put this into driving time. Okay. So a rate is when you have a ratio, but they have different units of measure. So here we worked on like weight to weight and distance to distance. But what if you have distance and time, like 60 miles in 2 hours? Or if you have 3 donuts for every 2 students. That's a better ratio. That's pretty good. Okay. Whenever you see per, we talked about per earlier. The per means the dividing line. So 60 miles per 2 hours. Or we have 3 donuts per 2 students. Or if you're like zooming through your test and you answer 18 questions per 5 minutes. There you go. You want to figure out how many is that. Actually, let's change that 3. We'll change that change that 5 to a 3, I mean. Okay. Now, what happens when you take a rate and you divide it by 1? Well, when a rate is simplified so that it's all over 1, need a new color, we'll go with pink. We call that a unit rate. Why? Because 1, like uno and unicycle and unicorn, that's where we get the unit from. So we call that a unit rate. So how do we do this? Well, we actually do the math. We simplify it. If we took our 60 miles per 2 hours, that's 30 miles per 1 hour. Or, if you will, 30 miles per hour. Or, if you took your 3 donuts for every 2 students, that's the same thing as 1.5 donuts per student. Or, if you did 18 questions in 3 minutes, that's the same thing as 16 questions per minute. Nice. That's good. Good job. All right, cool. Now, if we use this in real life, to solve problems with rates, we're also going to use conversions. Excuse me, I'm about to hiccup again. Nope. We do this process called dimensional analysis. Do this in chemistry a lot too. Call it stoichiometry. And I spelled that wrong, didn't I? Dimensional analysis. Okay. Ready? Here we go. Here's an example. So Josh and his family drove 400 miles in 8 hours. Here we've got a unit of distance and we've got a unit of time. I've been using these colors all day. It's time for new colors. We've got a unit of distance. He's going the distance and he's going, never mind. I don't know if that's, Anyway. So Josh has got a unit of distance. He's got a unit of time. This will give us a unit of speed. Shoot, I jinxed myself. All right, here we go. Thank you for your patience. They drove 400 miles in 8 hours. Today they need to drive another 700 miles. If they keep their rate the same, if they keep their speed the same, how long will it take to drive 700 miles? So what's our question? What are we asking here? How long? We don't know the time that it will take. So what should we do? Let's set up a conversion. Let's set up a dimensional analysis. Okay, what do we know? We know that they drove 400 miles in 8 hours, so we need to find out how long it will take to drive 700 miles further. So let's write this as a rate. We've got our 8 hours. I hope you're okay with me abbreviating. And 400 miles. Nice. If we want to do that as a unit rate, we need to simplify this a little bit. So I see that 400 is equal to 4 times 100. And I see that 8 is equal to 4 times 2. So now we can simplify this fraction by cutting out a 4, by reducing out a 4 on top and bottom. So that's 100 over 2. Oh, but guys, we're not done. 100 is equal to 2 times 50, and 2 is equal to 2 times 1. We can reduce even further. By the way, if you reduced an 8 out right away, good for you. I'm so proud. So that gives us an average of 50 miles per 1 hour. Excellent. We nailed it. We got our unit rate. What color did we make unit rates? It was like this weird green, wasn't it? We got our unit rate. Why? Because it's divided by 1. Oh, shoot, I misremembered. Our unit rates were pink, like this magenta guy. Nice. Okay, awesome. Now, we know 50 miles per hour. We're so close to being done, you guys. But our question is 700 miles further. So we'll want to multiply 700 miles further. But guys, we need to do a quick little trick. So we don't know what time it is. That's our question. How much time will it take? But if we multiply these guys across, we'll just get miles squared over hours squared. That's not going to work. So instead, we're going to take our conversion and we're going to flip it upside down. Because, it works more in theory. So instead of writing 50 miles per 1 hour, we're going to call it 1 hour per 50 minutes. And now watch what happens. The hours cancel out. And the minutes, and by minutes I mean miles, the miles, I did it again. The miles cancel out. And we multiply across. 1 times 700, my favorite thing. Oh, shoot, but now the whole thing's upside down. Ugh, dang it. Shooties me goodies. Redo. No, that's okay. What did I do wrong? Did I set the whole thing up wrong? No, we're good. We're good. We're good. We're good. We're good. Technically, I didn't need to put this here. I don't want this here. I just wanted 1. That's what I did wrong, because it'll come out hours on top. So you have 700 hours for 50 miles. There we go. All right. And then those are both divisible by 10. Those are also both divisible by 50. And this is going to come out to be 14. Oh, these canceled out. Why did I put miles? So it's just 14 hours. Now, we're not going to check our work super pedantically. We're just going to see, does that seem right? 8 hours for 400 miles. We almost double. We almost go twice as much. Almost. 400 to 700 is almost twice as much, but not quite. It's a little bit less than twice. So with this 8, and our answer time was 14, that's almost twice as much, but not quite. So we probably did something right. So there we go. We did it. We set up our conversion. We needed to make sure that our units cancel out. That's important. Let's write that down. Units need to cancel out. And by cancel, I mean reduce. That's why we flipped the guy upside down. Sweet. You won't always need to flip, but we just happened to need to in this one. Amazing. So there you have it. Rate, so whenever you have per, unit rate is something over 1. And when you convert, make sure your units line up. And have a wonderful time with your homework.